Okay, so I think we can start because always we are 2 minutes over the limits. So, and the speakers today are myself, Andreas Peror, and Massimo Pagani, which is our product manager. I'm a global account manager at the GEM International, and with experience in automation process application. I'm a functional safety engineer. Massimo Pagani is our product manager, and also has a very good experience in products, especially is our front end with for customer assistance. So he's always connected with our R&D support, and has a very complete overview of our production product and the application. And let's say resume a little bit what GMI is. We are an international company that produces intrinsically safe and certified devices for automation main packages, DCS, CSD, fire and gas, tips, and so on. We have 40 experience. We were founded in 1993, but our former company where we born was Electron Instrument. We also produce completely in our facility in Milan. We don't produce abroad, but we have a global presence in all over the world. And that is a little bit about our organization. We have 10 offices and in different strategic countries. We are 75. We have distributors in countries where we are not present, of course. And 200 people, total staff. We organize also functional safety and cybersecurity EX courses per year, 20. A lot of webinars, as you can see from the today webinar. And we have also installation, node continents, main projects. As we say that we have a complete state-of-the-art technology, product traceability for incoming and outgoing products. We also test every single unit in that we are sending to the customers, and we have also highly automatized the production. And last but not least, we have a 5 years warranty for all products, and also 10 years guarantee availability once the product will be declared discontinued. Important for customers are also the certifications. We have all certification for all kind of markets that you may meet on your applications. Also functional safety certification for the product, seal, and for the design also. Systematic capability. And also we have certifications, we say, for Americas, for Russia, for Europe, for China, for Japan, Brazil, and so on. This is the product range, producing intrinsically safe barriers, isolators, safety relays, isolators, safety, also power supplies, multiplexer, termination boards, hard multiplex, surge protection, so all interfaces that are between, let's say, the field and the system we produce, that are, let's say, used in combination with the safety systems, safety PLCs, and DCS. This is about our customers. So we have divided by system vendors, EPC, OEMs, and the users. You may find, I think, some of your customer already. Then we can talk about the topic of today, which are intrinsically safe isolators. Okay, so not from the product point of view, but also from the, let's say, the application aspects that are most important for you. Let's say we are dividing in chapter this presentation, where we have 4 chapters. So first is the protection methods and intrinsic safety concepts. Second one is IS isolators and so on. So we see the Modbus interface and also the connections. So we have first Paul Okay, so we want to know if what is your knowledge about this market. So let me go to the poll. Okay. I want to answer if you can answer what do you expect and what do you know about the basic protection principle for intrinsic safety. If it is isolation, mitigation, segregation, prevention, containment. There are different, of course, protection methods you may find. And for different applications, we are in a specific one, which is the, of course, intrinsic safety. And of course, they can be protection method can be realized in different ways, with the housing, with the pressure, with the electronic or electric parameters, and so on. I think most of you already answered. I'll leave another few seconds and I will stop it and I will let you know what is the right answer. I see that most of you, let's say, answer correctly. Okay, we can stop now. So we can, so some of you answer isolation, some of you prevention, the other were not. Indeed, say the answer correct is prevention. So you can see here how to power and read the signals from the field device installed in the hazardous cell. There are different methods, as we said. Principle, segregation, so it can be encapsulation or immersion or pressurization. So where you have EXP, EXO, EXM, EXE application. You can have also containment called flame-proof, EXD, the big housing especially. And the prevention where we can allocate it, increases safety and intrinsic safety. Where we are. And so this is intrinsic safety is very interesting because it's most flexible and cost-effective solution because it's realized by electronic circuits that prevent the sparking in the hazardous areas. And between the hazardous area and the system side, you can use this kind of interface, which is called intrinsically safe barrier or just barrier. And the unit is installed in the safe area or even in zone 2 can be if the certification is available for that area. So should we use the digital isolator intrinsically safety application? So the thing is, the isolator that limited the power for intrinsically safe circuit by restricting the amount of electrical energy to low limits. So in case you won't cause any spark. So in this case, if you want to use this kind of digital isolator, the isolator must not be designed as a standalone apparatus, but is one of the components, the IS circuits. So just isolator is not sufficient for, say, avoiding any sparkling situation in for explosive atmosphere. Okay. So, and what are the different intrinsic safety applications for IS isolator? You can have different. You can have analog circuit, can be input-output. You can digital, you can input and output. You can use also signal converter. So you want to convert the signal from hazardous area to safe areas. You can use a trip amplifier, serial line converter. And you can have other specific, very specific, like a load cell, where you are weighing application. You have vibration transducers. You have a frequency input that is a converter. You can have a temperature, flammable, or smoke detector. There are different applications for the digital isolators. But there are also different in the past. We were, let's say, you were probably also used to apply Zener. So the Zener is just an isolator from hazardous area and the safe area. In this case, the isolators or the digital also include the other features like wide range input-output signal, features like source sync current signal to the PLC DCS. So you can have a different option because the PLC DCS also is designed different ways. So some is sync, so it can be or it must be coupled with the source signal. And some is source, it must be coupled with the sync signal. So there are different associations. There are units with the digital bus communication, for instance, Modbus. There are units with burnout detection, burnout fault detection, especially for temperature, high accuracy multiple isolators, unit with the programmability of certain operating parameters, and also unit that can have or can be used in different installations. So in the D-Ray with also D-Ray with the power bus or in customized termination. If you have any questions, just pop up on your Q&R button bar. You can ask the question. We can stop anytime, no problem. And if you look now, we can see the difference between the second chapter, which is included IS isolators, solution application for AI, AO, DI, DO, temperature loads, and field bus. Hope Massimo is popping up now. Okay. Maybe it should be now online. In the meantime, we can go on. Massimo, are you here?
Yes, I'm here.
Okay, finally, good.
Can you hear me?
Yeah, we can hear you, no problem, fine. Just you have a small, let's say, picture view, so you can enlarge a little bit your camera view. Okay, and this is another poll. What solution do you usually apply in your applications? We have another poll. So we want to know what kind of solution do you usually apply, like intrinsically safe isolators, like Zener barriers, and we already mentioned, like the PLC DCS with integrated IS inputs. There are lots of solutions. Other, we can use EXP solution. So we see that most of you use intrinsically safe isolators. Some is still Zener barriers because it's still used, and mostly for spare parts or for, let's say, use for old systems. And some of you use already PLC DCS with integrated IS inputs. Okay, so thank you for answering. Massimo, are you okay?
Yeah, just a moment, please.
Okay, no problem. I can go on because it's still my part, no problem. So for analog inputs, what we can offer, what are the main features? So we are using isolators that have 420 milliamp current repeater. The input in this case can be active, passive. Active when the transmitters, this is usually we say, some differences you may find on other interlocutor, of course, because active passive is always challenging discussion. So active, we say that when the transmitter is 4-wire, 3-wire, so it's have a special auxiliary power supply, and the 420 loop that goes in this case to our isolator is active. We call it passive when we are talking about 420 2-wire, only 2-wire. So the power supply goes through the 420 milliamp loop. Okay. Other features are like a signal duplicator. I will call it also source sync out. Source sync out is we are differentiate input, field side, and output, which is the system side. In this case, can be source or sink. So source, when we are from the transmitter, we generated 4220. Sink when we generate by the external power supply. That is, let's say, generated by the system or by an auxiliary power supply. Can have voltage output, art compatible, and what we are offering is a CL2 and CL3 certification on different situations. We can have also the same unit or other unit that can be used for for duplication. So in this case, you have one input generated from a field side, field device. And in this case, the output is can be returned, can be retransmitted to the system or to two systems, two inputs probably from all your system, also with different standard milliamps and also watts. Okay, and you in this case you retransmit two different, so probably used for redundancy application. The input can be also is available also with the external source part. So the duplication is valid. The circuit duplication is valid both from for active or passive transmitters. Okay, no questions, so we can continue on this presentation. We also have a solution with a 4-channel, multiple channel. So in this case, 4 to 20. Just remember, explain you. In the slide, you may see two pictures. One is for the intrinsically safe isolators with a blue label, and one is for the standard isolator, for non-IS application. So 6000 with a green. So in probably almost all units we can have the double solution. In this case, we have a double solution for 4-channel with a 0, 4 to 20 milliamp current signal. The unit is a PC configurable, can be used as a full multiplexing input and output. So we can have a software that generates not generate, but configure the input or the output equal to the sum addition. It's a small controller in this case. So it can be used also splitter or duplicator by 2, 3, or 4 times the input. So the same input I can send to 4 different output to the system. This unit is also available with the Modbus interface. It can be also is a source output and is also certified for CL2 applications. We have also unit with trip alarm, so one unit that can be used as a 4 to 20 milliamp retransmission to the systems. With and also have 2 relays. The relays can be used for trip alarm, that's active, for low alarm, high alarm, mid alarm, different alarm that is also PC configurable, and the alarms, the output, and the range also, of course. And it's available with the CL2 certification. Also in this case, we have a solution for IS and non-IS applications. Massimo, are you online?
Yes, I'm online. And
okay.
I apologize for the inconvenience.
No problem, Massimo. It can happen. It's the inconvenience of a live webinar, because it's not recorded. So in this case, any situation can happen. Okay, there is a slide where maybe you can also say something if you like.
Yes, let's try to move on, and let's see now how analog input devices can manage a line fault. For 20 milliamp signal allow us to standardize the measurement, and using the Namur standard, we know that in the range between 3.6 milliamp and 21 milliamp, the measurement is valid and correct. The analog barriers allow us to read and mirror a signal that goes from 0 to a maximum of 2630 milliamp toward a PLC DCS system. In fact, the barrier has the main purpose of limiting the current in the loop to a non-dangerous level, which allows us not to generate a danger of explosion. This precise standard allows us to program our PLC to provide us with a line fault when the set thresholds are exceeded, or in case of using devices with programmable alarm threshold on board, to provide a single fault contact or cumulative fault to a DCS system. Let's now analyze how to obtain a correct system redundancy through trip amplifier devices. One of the typical applications which uses a redundant system with several devices, analog in this case, is what we can see in the following slide, where a 2 out of 3 redundant system of a trip amplifier is used to activate our final element. This system and its redundant logic allow us to replace more complex systems composed of safety PLC, allowing us to save more engineering cost. But let's see specifically. The free trip amplifier devices each have 2 alarm relay outputs with individually programmable threshold, and each of them is SIL2. By programming all the alarm threshold of the trip amplifier in the same way and connected in the way we see in the slide, the relay output in such a way as to compose a matrix of contacts which allow us to obtain a SIL3 level from a component SIL2. To activate the final element, at least 2 of the 3 loops, sensor plus trip amplifier, must perform the same variable measurement in the field and correctly process the data. In fact, when at least 2 out of 3 sensors detect the same variable in the field, the related trip amplifier will activate their contacts, and consequently the final element is activated. If one of the elements in the field fails, or if one of the trip amplifier fails, the 2 out of 3 redundancy allow to maintain our safety function and process availability at an high level. I repeat, this type of logic would be possible in another way, only by using a PLC system with redundant cards, having a considerable higher cost. This system allows us to achieve an high SIL3 safety standard with high process availability. Please, Andrea, it's your turn for the analog output card.
Okay, thank you, Massimo. So we coming back to good situation with the audio. And so the analog output, we have a solution with the 40-20 milliamp current drivers. Of course, we are talking about with the hard compatible modules with the possibility of a signal duplication also. So in this case, the duplication is realized by 1 input from the system and 2 outputs to the field, and SIL2 valid, and also with loop monitoring, so open short circuit reflect high impedance alarm. And Massimo maybe can explain a little bit better about this line monitoring.
Yes. And also in case of the analog output, let's see how a line and or load fault is managed. In this case, it's the barrier itself, in addition to limiting the current and voltage toward the field to non-dangerous levels, that carry out a real diagnosis of the loop towards the hazardous area. In fact, the internal circuit of the barrier is designed to provide us with a real fault signal when very precise thresholds are exceeded. In fact, in case of the GMI device in the slide, it's able to detect a short circuit fault when the impedance of the load and the line falls below 50 ohms or 100 ohms. This threshold can be set via internal switch. However, as for the open circuit, it's signaled when the threshold given by the formula 21 volt divided loop current minus 300 ohm, 750 ohm in this case, is exceeded. This threshold, as you can understand from the formula, is strongly dependent on the current that the PLC supplies to the loop. But how is this fault reported to the system? There are two ways. The first involves the use of a fault contact which is opened when the fault is detected and sent to a digital input card of a dedicated DCS system. In addition, a LED on the barrier, red typically is turned on. And the second method is the mirroring of the fault directly to the analog output card of the PLC. If the PLC card is compatible with this system and the supervised analog output card is able to detect a change in impedance at its input. This system allows not to use a dedicated DCS and to save costs related to it. In fact, when a fault is detected, the barrier's input circuit goes into an high impedance condition, typically higher than 5 kilo ohms, causing a maximum current lower than 2 milliamps to circulate in the input loop. In this way, the PLC analog output card, if supervised and able to receive this impedance variation, will understand that a fault has occurred in the field and will signal a fault. This system guarantees considerable saving in terms of cost, as it supervises the loop without the need to add a dedicated DCS system for this purpose. Now, let's see how it's possible to manage a redundancy system for analog output type applications. In this specific application, the management of two 420 milliamp signal towards the dangerous area is not a simple solution, as the two signals should be mixed or added in some way. GMI has developed a redundancy system through a special termination board, which takes the two signals coming from two analog output cards of two different PLC systems and mixes them through its how process logic. In fact, we will have a main common signal called master and a support of it, a common called slave. The two signals arrive at the terminals of the termination board and at the input of an electronic switch placed on board it. If both signals are regular, the master commands the loop and drives our load in the field. When this master signal fails due to a line fault or because the relative analog output card fails, the current signal relative to it goes to zero, and the electronic switch placed on the termination board switches to the slave signal, making ensure that the output load continues to be correctly powered. When the master signal is restored, the electronic switch on the termination board switches back to the master signal. In addition, we can say that the switching speed between master and slave will be less than 1 millisecond. Through this switching logic, it's possible to carry out redundancy also for analog output circuit. And there are two different concepts for the use of redundancy. The one that looks at the safety of the process, and the one that looks at the availability of the process. The two philosophies of redundancy are in contrast with each other, and the end user must choose which way to go. GMI's analog output redundancy satisfies the concept of the process availability, allowing our plant to continue its work even if one of the components in the field fails. GEM solutions try to simplify the redundancy logic to try to obtain the best possible result. Andrea, it's your turn for the digital input device.
Very good, Massimo. So we have talked about analog input, analog output. We have a switch for digital input that's suitable for seal-free application. Input is for proximity sensors on switch. There is also full monitoring and alarm out and duplication capability. And we can realize also application with this unit that are suitable for seal-free and for AS and non-AS application. In this case, also we can show also the duplication functionality can be used realized with this unit, where you can have one input, the other is short-circuited, and the second, the output is available on the right side. You see that there is output 1 and the output 2. The output 2 can be used as a duplicator or fault in this case. It's just a question of simple configuration. We also have application for advanced functionalities. In this case, also with loop monitoring for PIC/DCS cards. And in this case, this unit is operated as a current generator, where you have different current that correspond to a different situation. So for input, open in this case, or close, there is a specific current values. When you have a fault, in this case, line break or short circuit, the current is of course equal to 0 or something like that, between 0 and 0.4 milliamp. And we have high current between 6.5 and 8 milliamp condition current that simulate the short circuit. This is the proximity level current, the proximity level current. We also do have a solution for 8-channel with multiple channel. And as for the 4 analog input modules, there are logic functions side. So 8 input can be independent each other, and the first output corresponds to the first input and so on. Otherwise, you can select the specific functionalities and have a sort of matrix functionality size. This is also available with the Modbus interface, and of course there is a full loop monitoring for open and short segments. Massimo, you can say something about the fault detection?
Yes, Andrea, yes. Thank you. GMI has developed two particular digital input models, SIL2 and SIL3, capable of transparently transferring the status of an AMUR sensor or contact in the field to a supervised digital input card of a PLC. This allows our safety system to know exactly the state of the loop in the field. And furthermore, this transparency makes it possible not to use a dedicated DCS system for detecting a fault, as in case of using a normal digital barrier, which needs to interpret two contacts to understand the state of the input loop. But how does this transparency work? Well, through a network of resistors connected to transistor, the barrier output is able to provide the exact state of our input. In fact, when the contact in the field is in open condition, we will have the transistor in series with the output loop active and with its contact closed, while the transistor in parallel to the RH minus RL resistance open. In this way, an impedance value equal RH will be seen by the PLC. The PLC digital input card, which applies a voltage typically of 24 volt DC to this impedance, will read a return current value corresponding to the zero state of the contact. On the other hand, when the contact in the field is in the closed condition, RH minus RL is short-circuited by the transistor in parallel with it, and the PLC will see an impedance of the value of RL. In the same way as before, the digital input card that applies a voltage to the loop will read a return current value equal to the closed state of the contact in the field. But what happens in the event of a fault detected in the field? In the event of a fault in the field, whether it's a short circuit or an open circuit, the transistor in series with the output loop opens, and an high impedance is shown towards the PLC digital input card, which is read by the PLC as a bad signal or a fault. This network of resistor at the barrier output allows us to obtain a mirroring system of the fault towards the PLC. Let's see now some particular application involving digital input isolators. The typical application is where we have to isolate a voltage-free contact or an Amur sensor in the field. And in this case, we use the classic digital input barrier or an isolator. But what happens if in the field we have voltage, 24 volt, 48 volt, 110 volt DC or other, and we have to signal to our signal the presence or absence of this voltage? In this case, a digital input device cannot be used because its input front end is not available to accept external voltage from the field. In this case, we should use a digital output relay that is a device that, depending on the voltage that arrives at its command, activates or deactivates an output contact and communicate to a PLC DCS the presence of or absence of a voltage in the field. The classic example could be the one where we need to communicate to PLC DCS system placed in two different contexts. The digital output card of one of the two systems controls our digital output relay, while a digital input card receives the contact status of the digital output relay. What may be the main problem that can be encountered using a relay for this purpose? First of all, we have to keep in mind that usually a relay is designed to switch important values of current, while usually towards a digital input system, the currents in play are very low, typically less than 100 milliamp. In this situation, we can face problems of oxidation of the relay contact. Therefore, it's essential to choose a safety relay with golden plate contact, which consent a switching thanks to its high conductive performance, even current lower than 10 milliamp. To deal with this problem, GMI has equipped most of the relay of the new D5000 series with golden plate contacts to make them available to this particular application. In addition, GMI has developed an universal device able to receive at its input different voltage level, selectable via the switch, while the output provides a free contact voltage optocoupled type compatible with all PLC DCS systems, which ensures maximum conductivity even at lower currents. This device is specifically designed to work in this kind of application where we have to communicate between two systems distant from each other, or where we have to signal to a system presence or absence of voltage. Of course, diagnosing a wet contact in the field is difficult. How it's possible to understand and differentiate the closed state of a contact from a short circuit, for example? And again, how can we distinguish between the open state of a contact and an open circuit fault? This condition makes us think that diagnosing wet contact from voltage in the field is impossible. But GMI, through one of its analog devices, has studied a possible solution to overcome this type of problem and be able to provide diagnostics of a wet contact in the field. In fact, using a trip amplifier and connecting it with a network of resistors to the contact in the field, we can obtain voltage level at the input of the device that allow us to discriminate one state from another. Furthermore, by programming our chip amplifier with intervention threshold, we can provide the PLC with a different state for each condition of the input contact, being able to diagnose the normal operating state of the contact from a fault state. Let's see, for example, a wet field contact from 1025 volt DC. The diagnosis of a voltage is made possible through the use of a specifically programmed D62554S and with the insertion of some partition resistor to make the 125 volt DC compatible with the input voltage input of the D62554S. In the slide, we can see the diagram and the configuration of the isolator used for the test. And the resistor at the output of the isolator are used to provide the PLC digital input card with the necessary diagnostic value. So we will have that with S1 contact open at the output of the device, a resistance level will be presented, which will be read by the PLC as an off state, absence of the voltage in the field. Contact S1 close, it will give us a resistor level that the PLC will interpret it as a non-state present of the voltage in the field. The third state, fault in the field, cable break at the input, we will have a fault at the output with the opening of the relay commanded by two alarms. In this case, the PLC will see a fault status. Clearly, the PLC card must be of the supervised type. The output resistance on the device can be changed if necessary, if the application are requested. I choose the value very close to the to-dos of the D5038 device, which currently represent the universal version for all system tested so far. The input resistance must be suitable size in terms of power. We recommend to put a resistance of at least 1 watt of power.
But in any case, you can contact us if you have such kind of application, special applications.
Yes. Well, Andrea, it's your turn.
Yeah. Thank you, Massimo. So let's go with now with the digital outputs. So we have solution with the loop powered signal, control signal for CL3 applications, and for single dual channel. And in this case, there are different selectable outputs that may be used with the different loads, because also for safety reasons, you can, or you maybe need more power. In this case, you can select different outputs. And also we have a solution with auxiliary power, which grants to the system, to the load, let's say, more power than the ones given from the system. And in this case, there are 3 different selectable outputs, this also to match different loads, and with the loop monitoring, like such open and short circuit, suitable for CL3 applications. We also have a different multiple channel solution that you see that the size of the modules is increased with a functionality like Modbus output and complete full multiplexing. In this case, there are 11 different selectable outputs. It is a very, say, useful and flexible device for lot applications. Massimo, maybe you can explain a little bit better what we mean line monitoring for digital outputs.
Yes, also for digital out modules, GMI offer model with onboard line and load diagnostic to monitor loops in a hazardous area. The model D5040AS loop powered and D5049S bus powered, based on the impedance of the load in the field, are able to check the health of the loop and, in the event of a fault, generate a signal to the PLC directly to the digital output card mirroring function, or through the classic voltage free contact to a dedicated DCS digital input card. The D5040AS, being a loop-powered barrier for normally energized load, is capable of monitoring the impedance of the input loop when the load is on. If it sees an impedance below 50 ohms, it detects a short circuit fault, and on the PLC side, it transfers the information directly to the digital output card, showing an high impedance, which translates into a loop current of less than 2 milliamp. When the impedance of the load on the other end exceeds 10 kilo ohms, the barrier sees an open circuit fault and, in the same way as before, show an high impedance to the digital output card of the PLC. The signaling of a fault can also occur through a voltage free contact to be acquired through a dedicated DCS, or through a fault LED placed on the front of the barrier. The other model, the D5049S, on the other end, being bus powered, provide a complete diagnostic towards the field, both in condition of load on and in condition of load off. Like the D5040AS, it can transfer the fault information directly to the digital output card of the PLC with an impedance variation, or through a voltage free contact to be acquired with the digital input card of a DCS dedicated to the purpose. Let's now take a look at the redundancy problem also for intrinsically safe digital output application. Basically, there are three ways to obtain the redundancy of this system with three different level of redundancy. The first redundancy system involves all the elements that make up the loop, from the valve in the field to the intrinsically safe barrier to the PLC card that control the loop. This is certainly the most effective and safest redundancy system, but also the most expensive, as to create the redundancy of all elements of the loop has considerable cost. The intermediate way would be to redundant all the devices except the final element, that is the valve. This means having two barriers and two cards controlling the loop. The main problem that arises in this case is that the redundancy up to the barrier forces us to mix the output signal to the barrier. This is feasible from the theoretical point of view, but first of all, it involves the rating of the intrinsically safe loop from EA to EB, which means that the final element cannot be installed in zone 0, but only in zone 1. And also involve the difficulty to find a final element compatible with the safety parameters that are added, having to put the output of the two intrinsically safe barriers in parallel. This is certainly the most complex method to implement. The simplest and cost-effective way is the one proposed in the slide, where redundancy is obtained up to the digital output card of the PLC. After that, through two diodes, we mix the common signal coming from to the diodes at the input of a single barrier that guides our final element. This is the simplest system, as by not performing operation that add a current in the hazardous area, there are no problem in terms of compatibility with the final elements, and moreover, it's certainly the cost-effective solution, as the redundancy of the devices reaches the PLC only. In the next slide, we encountered a digital output application where we were asked to be able to control a final element, typically a valve, by controlling it with two digital output cards. The final element normally energized must be de-energized only if both digital outputs give the switch off command. This solution studied to obtain an high availability to the process and to keep the plant always active in order not to have losses in terms of production cost, can be obtained through a double channel seal-free relay with the output contact placed in parallel. In fact, this way, the load will be de-energized only if both digital outputs give the shutdown command. Of course, this solution is to the disadvantage of safety, as putting the output contacts of a seal-free relay in parallel leads to an increase in possible dangerous failures. But thanks to the GMI relay, we are still able to maintain a SIL2 level of the application and to obtain an high process availability. A different application where we were asked to create an high security loop, where the final element was de-energized when only one of the two digital output cards send a shutdown command. In this case, always using the same double channel seal-free relay, the desired safety function can be obtained by placing the relay output contacts in series. In this way, the seal-free level of the loop is increased to obtain the required function. This application makes us understand that sometimes it's possible to increase the safety or the availability to the process by combining low cost but very smart solutions, such as those proposed by GMI. Well, Andrea, it's your turn.
Okay, Massimo, thank you. So let's go further. So the temperature module, like isolator and converter. There was a question from 102D. What are the differences? I keep in mind now. And between isolator and converter, isolator is just to answer this question. Isolator is just a unit that isolated input to output without any modification. While a converter or signal conditioner, as I call it, is conditioning, is converting the signal into another standard, such from in this case, from thermocouple PT100 to 4020 milliamps. And this is the purpose of this unit, which is those units that we can convert temperature signals with different standards from RTD or thermocouples to 4020. Output can be source of sync with the fault out, Modbus out, and so on. We have also the same unit as a user, or it's a similar unit used as isolator. So in this case, we are repeating the standard from the field from PT100 to PT100. This is used when the system card is able to read directly a PT100 or thermocouples. But of course, the application is for IS. So in this case, a barrier or isolator, certified isolator must be used. We have also a unit with triple alarm. So in this case, a triple alarm for temperature applications, 2 alarms, 1 or 2 alarms, can be set as a low alarm, high alarm, whatever it needs, with the Modbus configuration, Modbus also interface. And Massimo, we do have a question, so you can check on the Q&R, so we can answer right now, probably at the right time. Are you reading that?
Yes, we have a question from our attendee. When we install ES isolators in junction box placed in non-hazardous area, do we need to mark that the junction box as ES? Outputs from junction box are used for design devices installed in hazardous area. Well, Andrea, yeah, please.
No, I think the question is we installed the isolator in the junction box, which is in non-hazardous area, but the connection with the field is in hazardous area. So the field devices are in hazardous area, and junction box is in a safe area where there are the isolators. The question is, do we need to mark that junction box as IS? The answer is yes. So because you are connecting the system in with the field instruments in certified area, zone 1 or zone 2 or even zone 0. Okay, so let's go further. It's your time, Massimo, with the software. We are also talking about configurable modules. So here we have an application, or maybe we can explain a little bit better about the software.
Yes, Andrea, a few words about the configuration software of the GMD 5000 series battery. Through this software, it's possible to configure and read all the parameters related to our devices and variables in the field, save and reload data and configuration in a local hard drive, monitor the variables in the field in real time. To verify the correct functioning of the loop and finally record the monitoring session and save them in a file. The software is free and downloadable from our site and absolutely compatible with all Microsoft Windows systems. In the slide, we see the configuration window of our D5072S temperature converter where it's possible to configure the type of input sensor, including thermocouples, RTDs, potentiometer, or signal in millivolt. The output parameters are fully user configurable. The possibility of creating a custom table is also available, where for specific application, the customer can create a table of input value for particular sensor, such as a PTC. And again, the monitoring session, where it's possible to check the parameters of the input variable and the health of the loop in real time. All our D5000 series device can be configured with this software to perform their main function or to obtain special function. Well, Andrea.
Yes. In our product range, we have also solution for waning application. Load cell, is also called strain gauge when for waning system, where you can connect a load cell and convert it to 4 to 20 milliamp per signal. A load cell, just a repeater, when the system is able to read directly load cell. Those units are configurable with PC with a Modbus configuration and also alarms, and also field calibration. We also have vibration monitoring application for vibration applications, so where for motors or turbines, where there are vibration transducer that send a specific signal from which a standard is which is -20 up to 0 volt, and 2 or 3 wire supported. We have probably a slide where we explain a little bit about this application, Massimo.
Yes, particular applications are those involving devices such as accelerometers or vibration sensor. Accelerometers are devices that measure the vibration or acceleration of the movement of a structure, the force generated by vibration or a variation in the movement causes the mass to compress the piezoelectric material, which generates an electric charge proportional to the force exerted on it. Since the charge is proportional to the force and that the mass is a constant, the charge is also proportional to the acceleration. Transducer for measuring acceleration and vibration are increasingly used in the mechanical and structural field, vehicle testing, industrial monitoring, and predictive maintenance, benches and rooms test, aerospace experimentation, and so on. When this accelerometer operated in a classified area, they must be isolated through an intrinsically safe barrier. As in the slide, the D5062S isolates this particular type of sensor, transparently providing the reading system placed in the safe area with a waveform of the same level and frequency as that generated by the sensor, so that the system can read the signal correctly. It provides a fully floating DC supply for energized vibration transducer, accelerometers, or 2 free wire sensors located in a hazardous area, and repeats the sensor input voltage in a totally isolated circuit located in safe area. To drive vibration monitors or analyzer for rotating machinery control and supervision purposes. GMI can supply devices to isolate and power the different type of sensors present in industrial automation and beyond. Well, Andrea, it's your turn.
Thank you, Massimo. We came up to the end of this part. It's very sorry for maybe it's very long, but we have a lot of things. We have another small, say, short poll. If you want to answer what the feature is most important for IS interface, like a single channel, multiple channel, line monitoring, software configuration, seal certified, and math functions. We see that also seal certification is has been asked more and more for ES application, because besides the safety, for hazardous are the safety, or let's say the SEAL certification, which grants that the specific function is performed with very high probability, or certified probability, that is features more and more required from customers and from let's say critical application. Okay, I'm going to stop it. Thank you. And we want to go further. So it's we have a last part regarding Modbus interface. Massimo, it's your turn again.
Yes, many of our devices use Modbus to communicate. But what is Modbus? Modbus is a serial communication protocol that connects programmable logic controls. It has become a standard in industrial communication and is currently one of the most popular connection protocol in the world among industrial electronic devices. The main reason for such as high use of Modbus compared to other communication protocol are designed with industrial uses in mind. It's an openly published and royalty-free protocol, easy of installation and maintenance, and it moves raw bits and words without placing many restrictions on producer. Modbus allows communication between different devices connected to the same network. For example, a system that measures temperature and humidity and communicates the result to a computer. Modbus is often used to connect a supervisor computer with a remote terminal unit, RTU, in a supervisory control and data acquisition system, SCADA. There are two versions of the protocol on serial port RS485 by default, but also RS232 and on Ethernet. Each peripheral that needs to communicate via Modbus is assigned an unique address. Each of these can send a Modbus command, although generally only one peripheral acts as a master. A Modbus command contains the Modbus address of the peripheral with which you want to communicate. And again, only the latter will act on the command, although the other device also receives it. All Modbus commands contain control information, which ensure that the command arrived is correct. And the basic command can ask an RTU to change a value in one of its registers, as well as command the peripheral to return one or more values contained in its register. And again, Modbus RTU is an open serial protocol, widely accepted due to its ease of use and reliability. Up to 125 modules can be arranged in a multi-drop network and monitored configured by a single master unit, as shown in the following picture. Each slave contains a table of parameters. Each of them is unequivocal, identified through an address, and when requested, make available its value for reading or writing. Complete diagnostic information can be retrieved through Modbus multi-drop RS485 protocol if a Modbus master is available on the system side. Modbus devices communicate using a master-slave technique in which only one device master can initiate transaction called carry. The other device slave responds by supplying the request data to master. A slave is any peripheral device which processes information and sends its output to the master. A slave doesn't send any message before the master requests it, as there can be several devices connected on the same RS485 bus, each slave must use an unique ID on the bus. But what are the advantages of using Modbus communication? Well, with a single Modbus RS485 interface, it's possible to connect and communicate with all the devices present on the same bus. Multi-drop connection is possible, and communication can cover a distance of up to 1,200 meters. And another advantage is the possibility of not using a dedicated digital input system to monitor alarm. This allows us to have a significant saving in terms of cost. And again, real-time information on the type of alarm and on the health of the load and the line. It's also possible through Modbus, a complete remote programming of the devices. In the next slide, we see what are the Modbus devices in the GMI portfolio. For all products category, GMI provides a device that can communicate Modbus and be programmed through Modbus. Well, Andrea, we have now a slide with another application.
Yes, this one.
Okay. In this slide, we examine an application where a sensor installed in a hazardous area must communicate via RS485 with the control unit located in a safe area. The sensor located in the hazardous area must be isolated and powered through two barriers. One barrier will supply power to the classified area so that the sensor is protected and cannot generate spark that can cause an explosion. The other barrier will have to provide isolation of the RS485 bus line so that it can connect with the unit control. The advantages of using this specific connection is the possibility of connecting up to 42 devices in a multi-drop mode on a single bus, which allows us to form an integrated network of devices with considerable saving on installation cost. When installing a device with bus interface in an hazardous area, there are two ES barriers that need to be installed, a power barrier and a signal barrier. The signal and the power are two separate ES circuits, so they must comply with the proper ES segregation distance. The 1061 field bus isolating repeater provides proper isolating and driving of an RS485 intrinsically safe line located in a hazardous area, hazardous location, communicated with a RS485 line located in safe area, non-hazardous location. The unit also acts as a level translator, adding the capability to connect an RS242 line located in safe area and provides the proper line communication without the need of additional control line. The RS422 connection may be used on both sides instead of RS485 two-wire connection. And again, both the Profibus DP communication protocol and user-defined protocols are supported at baud rates from 1.2 kilobits per second to 1.5 megabits per second for Profibus DP, and from 1.2 kilobytes per second up to 150.2 bits per second for RS242 protocol. The unit provides the line termination capability on both hazardous and safe side. Well, Andrea, it's your turn for the conclusion.
Okay, thank you. We came to a conclusion. Sorry for taking your time so much, but there are a lot of information. We want to now give you more overview about the EX protection methods. If you look at explosion proof, where you have a certain safety, certain flexibility, certain installation cost and maintenance cost, we want to highlight that intrinsic safety is more safe because we are not including, so we are reducing the energy, we're more flexible, and installation maintenance costs are lower than explosion proof. And also is the only technology that allow live maintenance without disconnecting the power from the system. So it's in terms of cost, installation and maintenance, and flexible safety has much more advantages than an explosion proof. So, but I want to say also another things that the use of isolators barrier is not only sufficient to achieve safety on hazardous applications. So the total loop must be verified. So the isolator barrier certification must be compliant with the ARIA classification. Okay. The field device certification must be compliant with ARIA classification. So you cannot use a field device which is certified for zone 1 and using zone 0. The other way around, of course, is possible, but not in this case. And the safety parameter for the apparatus, field, and the IS isolator must match on, must match together. We want to tell you later how. Cable parameters must match also with the apparatus certification. You know that also, maybe you already know that if you have a cable that has a specific parameters, that cable is, or the parameters have a big influence if you say stretch this cable for longer distance, for very long distance. And also the max temperature must be compliant with the classification. Here there is an example. We have where you have the field apparatus and the barriers where there are UI, II, PI, CI, LI for the field device, and the barriers has a certain UO, IO, PO, COs in the allow. Don't want to go in details, but we have a tool on our website which is available, and you can check if the hours later you are using for the application match with the field device you are using. That is not is considered as a tool, is not certified tool that cannot be used for, let's say, for certification purpose, but is correct, of course, and that those parameters give you an idea if you use the correct unit or not. The latest slide is regarding Xenon. We have talked about Xenon and isolated barriers, and if you will look at the features, we see that the Xenon barrier is for cost is lower, very simple design, completely loop powered, has some voltage drop issues, and also is the most important things that must be used with the field device isolations. So the devices must be isolated, cannot be uninsulated, and also require dedicated earth connection. So the earth connection is very important for each Xenon barrier you're using with, and also must be frequently and check it. While isolated barrier is of course more expensive because there is a circuit is more complicated, is bigger, of course, but can be used with any sensor, with any filter speed, and don't require any earth connection. Well, we arrive at the end. No more questions from you. I think you are really tired. We make you sorry and apologize for that, but there are a lot of things to discuss, and maybe we didn't touch, of course, all things. But you can find any other information on our website, geminternational.com, such as documentation, product, base, certification, software, and so on. About our webinars, you may find our program and our scheduling on the website. So you can register for next webinars for EX, for functional safety, cybersecurity, and so on. We want to remind you also that this webinar is being recorded and it will be available soon on our YouTube channel, but you can find also all the others available. You can review and send to your maybe colleague that did not attend it. Thank you again. There is a last call. Sorry, if you want to answer how we did, because we are measuring and we want to improve our, let's say, capacity and message through our web. Is a very complete activity we are doing, and thank you for answering. You can answer as you like. We don't. You are anonymous on your answer. Thank you, and that will be is very important. If you have any feedback, you can write us later. And thank you. I'm gonna stop that, and we wanna remind you our email and our face and our address in case you wanna write us later on for any specific request. Thank you again to all our attendees.
Thank you, Andrea. Thank you all, to all our attendees.
Master, we don't see you, but we believe you. You are still there.
Yeah, no, I'm here.
Thank you. Thank you, all of you. Bye-bye.
Thank you. Bye-bye. See you.
Bye-bye. Bye-bye.